welcome back to my YouTube channel. Now in today's lecture we are going to learn about the Lewis symbol or Lewis structure for representation of your molecules or the ions one. So in the previous lecture we have learned about the Lewis symbol for an atom of an element. Now in this lecture we will going to deal with the Lewis symbol for molecules and the ions one. You know that any molecule or the ion is made up of number of atoms one, is it right? So again, how we can write the Lewis symbol for molecules or the ions? Obviously we have to combine the Lewis symbol which we have written for the atoms one. How to consider the structural formulas for molecules or ions one. Okay, we have to combine the Lewis symbol. So we are going to combine the Lewis symbol of an atom which is combining to form molecules or ions one, which is combining to form molecules or ions one. Is it right? Molecules or ions. So this is the important point you must remember. We are doing nothing new here. We are just going to combine the symbol of an atom in a molecules or the ion, which is generally called as an electron dot structure, or it is generally known as an electron dot formula, or it is also known as an Lewis structure one. So this is the point you must remember. What we are going to do to represent this molecule one, we are going to consider the structural formulae. Okay, structural formula for molecules or the ions one. Okay, now we know that this structural formula is generally made up of by combining the atoms one. Okay, so here we are going to combine the Lewis structure for atoms in molecules or ions one, molecules or the ions. Again remember, if we combine the Lewis symbol for an atom, we will obviously get the structural formula for molecules or the ions one. Now that structural formula is generally known as an electron dot structure, or it is also known as an electron dot formula, or it is also known as an Lewis structure, obviously for molecules one. And you know that if we have to consider the Lewis structure, we generally consider the valence electrons for all combining atom one, all combining atoms. Okay, this is about a simple introduction to this your representation of Lewis molecule or Lewis ions one. So again remember, if we have to write down the Lewis structure or Lewis symbol for a molecule or ions one, we have to consider the few steps one. So let us consider which the steps that are involved while writing the formulas one. So the steps involved for writing the Lewis symbol one. Okay. Now which is the step first? We have to combine the valence electron of all combining atoms to get the total number of valence electrons one. Now what is it? Valence electrons of all combining atoms in molecules or ions are added to get total number of valence electrons one. Okay, so this is the step first. Now for example, if I am going to consider the example of H2O molecule. H2O molecule is made up of two hydrogen atom and one oxygen atom one. If I have to find out the valence electrons in this molecule, we have to first of all consider the electronic configurations of all combining atoms one. So here only two atoms, oxygen, its atomic number is 8. So its electronic configuration will be 1s2, 2s2, comma 2p4, 1s2, 2s2, 2p4. Okay, and for hydrogen atom that will be the 1s1. Okay, now you have to find out the valence electron. We know that whatever the electron that are present in the outermost shell is nothing but the valence electron one. So here for one hydrogen atom there will be the one valence electron. Okay, and for one oxygen atom there will be the total 2 plus 4, that will be the 6 valence electron one. But this molecule is made up of one oxygen atom and two hydrogen atom. So here what we are going to do, we know that 6 valence electron for one oxygen atom and 2 into 1 valence electron for hydrogen atom. So that will be totally equals to totally 8 valence electron one. So that is our step. So what we have written here, valence electrons of all combining atoms in molecules or the ions are added to get the total number of valence electrons one. Okay, so in H2O molecule there is 8 valence electron one. Now let's go to the next step. So in the next step we have to consider if the molecule have one negative charge, it means one electron is added to form anion one. Okay, so that is our first statement in point number second. And the second statement is that if the molecule or ions, you can consider ions also, or ions have positive charge, okay, then the one electron is removed from the molecules or ions one. Okay, let us consider the example, then we will go to the statement. For example, if I am going to consider the NH4 plus, okay, ion, ammonium ion one. Okay, and let us consider the OH minus ion. Okay, now here we have to find out the total number of valence electron. So obviously nitrogen have how many valence electron? It will have the 5 valence electron one, plus one hydrogen atom have a 1 valence electron, so 4 will have the 4 valence electron. So total valence electron will be equals to 9. Okay, but as it is having a one positive charge, if it is having a positive charge, then that molecule lose its one electron. Here the total valence electron will be calculated as 5 plus 4, as there is a removal of one electron, therefore plus 4 minus 1, that will be equals to total 8 electrons. So in ammonium ion there will be the 8 electrons one. Okay, now let us consider the next example, oxygen. Okay, oxygen having the 6 valence electron plus one hydrogen will have a 1 electron one, and there is a one negative charge on this ion one. So if there is a negative charge, one electron is added, one negative charge for one electron one. Okay, so I am going to add one electron. So the total valence electron will equals to 8. So this is the meaning of this statement. Now next, that is third step. So here we have to consider atom with least electronegativity, least electronegative is written in the center, for molecules or ions one. It is very easy step. Now let us consider the example for this one. For example, SO4 2 minus ion. Okay, I have taken this example one. You know that the electronegativity of sulfur is actually 2.5, while the electronegativity of your oxygen is 3.51. Which is the least electronegative element? That is sulfur. So here it says that sulfur should be written at the center one. Okay, and it will be surrounded by the 4 oxygen atom one. Okay, so this is generally the structure of your SO4 2 minus ion one. So this is our point number 3rd. Now next, point number 4th. Now in the point number 4 we have to consider the skeletal structure. So number 4 we have to consider the skeletal structure. So generally the skeletal structure of a atom, the skeletal structure of a molecules or the ions is written as a symbol of combining atoms and valence electrons one. Okay, so in point number 4, the skeletal structure of molecules or the ions is written as a symbol of combining atoms and the valence electrons one. Now here I have just written the skeletal structure of that particular ion one. I have not mentioned the valence electron. Along with the skeletal structure, the number of bonds formed by atoms to form molecule or ions one. Okay, we know that whenever the shared electron pair is the bond formed by that atom bond. Now let us consider the example for this one. Let us consider the example NH4 plus ion 1. Okay, now here you know that as nitrogen at the center, and this nitrogen atom is surrounded by the 4 hydrogen atom one. Okay, that's it. Okay, now these valence electrons that I have shown here is nothing but the bonding pair one. Okay, so this is the skeletal structure of your Lewis symbol for molecules or the ions one along with its bonding pair one. Okay, now let's go to the next point number 5th, which is very important. After writing the number of electrons as a shared pair for single bond. Okay, remaining electrons, the remaining valence electrons are written as lone pair or used for multiple bond one. Multiple bond, that is nothing but for your either double bond or triple bond or the triple bond. Okay, so that is your point number fifth one. So here in the previous point we have studied that we write the skeletal structure of that molecule, okay, or ion one, and then we write the pair of electrons one. Is it right? We know that each pair of electron represents the single bond one. This is important point, remember. Okay, so out of the total valence electron, few will be write as a single bonding electron, or that is nothing but your single bond one, and the remaining is now considered as a valence electron one. Okay, now let us consider the example for this one. For example, let us consider the example of ammonia, okay, that is NH3. So here we know that nitrogen in the center. Now 3 bonding pairs first of all, okay. Again you know that the total valence electron will be the 5 plus 3, so total 8 electrons. So this is the bonding electron. Now how many electrons are utilized here? 3 pairs is utilized, so remaining 2 will be here written as a lone pair. So this is the meaning of this one, or either maybe you can use for the double bond. Okay, now if I have to consider the structure for this minus ion or sulfate ion, obviously here no doubt first we will write it as a bond pair, and now this will be the second bond pair. It will represents the double bond. Okay, so it will represent the double. So these are the 5 important points that we have studied for writing the Lewis structure for your molecule or the ions one. Okay, now let us summarize that again. The first point, we have calculated the total number of valence electrons from the combining atoms one. Okay, now in the second point we have considered that whenever there is an ion, okay, ion may be the cation or the anions. If it is cation, obviously it will have the positive charge, and we have to remove the 1 electron for 1 positive charge in the cations one, okay, from the total valence electrons. Okay, now in the anion, obviously exactly opposite, anion will have the negative charge, and we will going to add the 1 electron in our total valence electron in the anion one. Okay, so that is a very simple point. So in the point number 3rd, we have seen that the atom with the least electronegativity is written at the center of that molecule one. Okay, now in the 4th point we have considered the skeletal structure one. Now in that skeletal structure, obviously we are going to write the atom with the least electronegativity at the center, and then we are going to consider the bonding pair for that molecule one. Is it right? For all combining atoms one. Now in the point number 5th, it is very simple point 1. What will be the remaining valence electrons? Okay, now it will be read as a lone pair, or it may be considered for the your multiple bond one. So this is in short summary of your this particular presentation for your molecule by the Lewis structures one. Okay. Now let us apply this step to the example one, so we can draw the Lewis structure for molecules or the ions one. So here the question may be asked like this: write the Lewis structure of NO2 minus ion. Okay, NO2 minus ion. So we have to apply our steps one. So let us consider the step first. So step first, now what we have to do in this step first, we have to count the total number of valence electron. Count total number of valence electrons. And again you know that whenever there is a negative charge on any ion, okay, so we have to add the 1 electron on it. Okay, so due to the 1 negative charge, add 1 electrons in total valence electrons. Okay, So actually we have combined here step first and the step second one. So you know that we have only two atoms here, that is nitrogen and the oxygen one. Now what is the electronic configuration of nitrogen? We know that 1s2, 2s2, then 2p3, okay, and oxygen, that is 1s2, 2s2, then 2p4, okay. We know that each oxygen atom have 6 valence electron while nitrogen have the 5 electrons. So let us calculate the total number of valence electron for NO2 minus ion. That will be equals to, that is for nitrogen atom 5 plus, as there is a 2 oxygen atom, therefore 2 into 6 valence electron plus 1 additional for that negative charge. So total will become as an 5 plus 12 plus 1, and that will be equals to 18 valence electrons. Okay, now let's go to the step number second. Step second, now here we have to consider the skeletal structure of that molecule. The skeletal structure, the skeletal structure of ion, okay, that is ON will be the skeletal structure. Then next, third step, let us go to the step number third. Now in the third step we have to show the single bond between the two atoms one, okay, between this nitrogen and oxygen atom and between this nitrogen and the oxygen atom one, and we will put all the valence electrons on these three atoms one. So let us consider that step. So here we have to draw the single bond for completing the octet one, okay. So here we will draw that structure as like this, that is N O, then N O, okay. Now total 18 valence electrons, so I will write the 3 pair here, okay, then 3 pair here, then 3 pair here, and 1 pair on nitrogen atom. So count that total 18 valence electron: 2, 4, 6, 8, 10, 12, 14, 16 and 18 one, okay. But after you are drawing this particular structure, okay, and as we know that there is a negative charge on that ion one, but here you can observe that nitrogen atom have only 6 valence electrons one. So this particular molecule does not complete its octet one. So here if the nitrogen have to complete its octet, then obviously there must be the double bond between this nitrogen and oxygen atom one, okay, then and then only it will complete its octet. So one valence pair as a double bond pair one. So we will modify it as, hence we will modify this structure as a O 1 2 3 pair, okay, that means total 6 electron, 1 bonding pair. So these 3 pair are nothing. Now here if I am going to consider the double bond, okay, so here I have written the 2 pairs and 2 lone pairs on this oxygen atom, okay, and minus charge. Now here and nitrogen will have its lone pair, okay. Now you can calculate that this nitrogen also complete its octet, oxygen atom also complete its octet, this oxygen atom also complete its octet one. So there will be the formation of NO2 minus ion one. You can represent this structure also in such manner: O, then pair nitrogen atom, oxygen, that is the equivalent one. That's it. You may show the double bond here or you may show here, it doesn't matter. Both structures are the equivalent structures one. So if I am going to consider the dash formula for this one, it will be like this: O double bond N, single bond O. It will have the 2 lone pair, nitrogen will have the 1 lone pair, and this oxygen will have the 3 lone pair along with the negative charge one. Okay, so this is the structural dot formula for your NO2 minus ion one. So this is the very simple application of our steps which we have applied here one. Now let's go to the next example. So again, step number first, here we have to consider the electronic configuration of carbon atom, that is 1s2, 2s2. We know that carbon atom have the atomic number 6, 1s2, 2s2, then 2p2. Okay, while your oxygen atom again 1s2, 2s2, then 2p4. So the total valence electron will be, for carbon atom it will be the 4, for your oxygen atom it will be the 6. As it is the neutral molecule, it does not have any charge, so we don't have to add any additional electrons. So just calculate the total number of valence electron for CO molecule, that will be equals to 4 plus 6, okay, which is equals to the 10 valence electrons. Okay, now here we have to write the skeletal structure. The skeletal structure will be the, now in this particular molecule there is only 2 atoms, so the skeletal structure will be represented as an C and O. Okay, now we know that in the third step here we have to draw the single bond first of all and other valence electrons one. So draw the single bond. That means we have to show the one pair in between this oxygen and the carbon one. So this is I have done. We know that if we draw the bonding pair, the remaining will be considered as a lone pair or maybe used for the double bond or triple bond. So again the 2 electrons I have shown here, then the 3. So there will be the total how many electrons? 2 plus 2, 4, 6, 8 and 10. Okay, but as we know that this oxygen atom completes its octet. What about this carbon atom? It does not complete its octet one. It will have only 4 valence electron. So it requires the 4 valence electron. Now if I am going to consider the triple bond between this carbon and the oxygen atom, it will complete its octet. So we can write the Lewis structure for your CO molecule will be as like this: carbon with the 2 electrons, then between the carbon and the oxygen there will be the 3 pair, okay, while the remaining will have the 2 lone pair one. Okay, so this is the Lewis structure for your CO molecule one. In this manner we have to apply this steps one. So I have written the few other examples on the board which are very important one. You just do the one work, you take the screenshot of this one and apply our rule to this particular molecules or the ions one. Thanks for watching this video. See you in my next video.